We're going to continue the analysis of a truss bridge. In our first analysis, in the first part of it, we started by taking this bridge and summing the moments around a point, in this case point A. And we set that sum equal to 0. And what we found was the reactionary force at point C in the y direction was 150 pounds. We then summed the forces in the y direction, and we found that the reactionary force at point A in the y direction was 350 pounds. So this is where we've left off, knowing these two reactionary forces. But now, to actually design this bridge, we would have to find the forces in a member such as AB and such as a member like AD. So let's do that now. So I'm going to simplify or just draw a part of this bridge, the part on the left where AB and AD are. Okay, so what I want to do first is take that reactionary force at point A in the y direction, at 350 pounds, and say, okay, there is a force in member AB, which we'll call AB, and we're going to presume it's in tension. So it's pulling away from A. And if we were to sum the forces in the y direction, they should be equal to 0. And the two forces in the y direction are this reactionary force and the force AB, but the y component of it. So the y component of that, which would be over here somewhere, just vertical, plus this reactionary force have to add to 0. Well, we know the reactionary force is 350 pounds. We don't know the force AB in the y direction, but they have to sum to 0. We can do algebra by subtracting 350 from both sides. And what we find is the force in member AB in the y direction is negative 350 pounds. And so what that means is, because it's negative, that this member is not in tension, it's in compression. So if I was to draw this force AB as a vector, here, there is a angle down here, theta, which we don't know what it is yet. And we have a y component here, ABY. And we have an x component here, ABX. This is the force in member AB. So this forms a right triangle. And so now the second step to analyzing the actual forces in individual members is to do a trigonometric analysis. And so if we look at this triangle, we see that we know two of the sides. And so we could use the tangent function. Tangent theta is a trigonometric function defined by the opposite side of the angle divided by the hypotenuse of the triangle. All right, we don't know what theta is, so we'll just leave that as tan theta. But we do know the opposite side is 4, and the adjacent side is 3. Whoops, that's what I meant to say. The tangent is not opposite over hypotenuse. That's sine. Opposite over adjacent is tangent. So 4 over 3 is the tangent. 4/3 is 1.333. So we know the tangent, but we want to know theta. We can take the inverse of a trigonometric function, denoted by the -1 sign. So if we take the inverse tangent of tangent, we get the angle theta. And that means we have to take the inverse tangent of the other side, which in this case is 1.33. So if you do this on your calculator, take the inverse tangent of 1.33, you find that the angle is equal to 53 degrees. Make sure your calculator is in degree mode. All right, so now we know this. We know this is 53 degrees. So we know what ABY is. We know it's negative 350 pounds. So now, can we find the force AB? Well, we have a trigonometric function called sine, if you remember, which is opposite over hypotenuse. We know the angle, it's 53 degrees. We know the opposite side is AB in the y direction, or 350 pounds. I will leave the negative off. But we don't know the hypotenuse, but we do know that it's the force in member AB. So we only have one unknown, that's AB. Let's multiply it by both sides to get it in the numerator. That gets rid of it over here. Now we have sine 53 is still in the way. Let's divide both sides by sine 53 degrees. To get rid of it on this side. And now we have AB is equal to 350 pounds divided by sine 53, or 438 pounds. All right, so now we know the force, and that will be a negative because it's in compression. The force in member AB is 438 pounds. And so if you were a bridge designer, you would choose a beam that would support that weight, that force. All right, so there's one last thing we should do. We can find the force in member AD as well. And that will require us to sum the forces in the x direction. And they have to add up to 0. We notice that we have this x component of AB. And if we add it to the, we'll presume there's a force in tension in AD. If we add it to the force in member AD, they should equal to 0. We know that ABX has a relationship to AB and ABY, so we can find that. We can do cosine theta is equal to adjacent over hypotenuse. Again, the angle is 53 degrees in this case. The adjacent side to this angle is ABX, and the hypotenuse is AB. And so if we solve for this by just multiplying both sides by 438, we get ABX is equal to 270 pounds. And that's a negative 270 pounds. Okay, so now if we were to solve for the force in member AD, if this is negative 270, AD, to solve this algebraically, you would add 270 to both sides, and the force in member AD is 270 pounds. Again, in tension, pulling in that direction. Thank you for listening.